Welcome back to Anissa and Anna's math videos.
We're going to be helping you prove this trig proof.
Before we start, you need to know that cotangent equals cosine over sine.
So the goal of this trig proof is to get this side to equal this side, or if you want to start on the right side, it would be to get this side equal to the left side.
Today I will be starting on the left side because I think it will be easier, but you can start on the right side if you want. So looking back at what we just talked about, cotangent is cosine over sine. So I'm going to write cosine squared of theta, because it's squared up here, over sine squared theta.
And the next step is we're going to subtract our two fractions and we're going to make cosine into a fraction, and that is just cosine squared of theta over 1. And since we're subtracting two fractions, we always will have to have a common denominator, which we don't have yet.
Next step is going to make common denominators. So this is sine squared of theta, so I'm going to times this side by sine squared of theta. So once you do that, you're going to get cosine squared of theta over sine squared of theta minus cosine squared of theta sine squared of theta over sine squared of theta. And now we can subtract.
Okay, and just in a helpful tip, when you're multiplying this fraction over here by sine squared, you're multiplying it, as you can see, by sine squared of theta over sine squared of theta, because that is equal to 1, and you can multiply these fractions by 1. And so that's why we did that. But moving on down here, we're going to change these two fractions, and since they have common denominators now, we can put it into one big fraction here. And now our next step is to look for a common term. So in the numerator up here, we can see a common term of cosine squared of theta. So we're going to take that out.
So as you can see, we took a cosine squared theta because it was common in these two to simplify it down. So now this is what we have. But what is this? I think I forgot an identity. I can't find it.
Wait, Anna, what's wrong? Because I see an identity up there. Is that what you're talking
I
about?
don't see an identity. Where'd it go? I keep losing it.
Oh my gosh, it keeps getting lost. Here's your stupid identity.
Never letting go of this again. Now we can finish our problem.
Okay, now that we finally got our identity that Anna kept losing, we can recognize that this is a form of this identity. So 1 minus sine squared of theta. We can work with that and figure that out from this identity.
Okay, so I'm going to subtract a sine squared of theta from both sides. And I'm going to get 1 minus sine squared of theta, which matches this. So that means cosine squared of theta equals this. So we can take this out, and I'll just rewrite it because in proofs you have to show all of your steps.
Okay, so now, since we recognize 1 minus sine squared of theta is the same thing as cosine squared of theta, we can finish our problem. So when looking at this, we're going to make this, we have to get this to look something like that. And we can recognize that cosine squared of theta over sine of theta, just like we talked about in the beginning, is going to be equal to cotangent squared of theta. So that part becomes cotangent squared of theta, and we have cosine squared of theta already in our numerator. So now we have finished the problem. And since it's multiplication, we can switch them to match exactly cosine squared of theta, cotangent squared of theta. And there you have your answer. 3, 2, 1.
Oh. Thanks for watching.
And this and Anna's math videos,
Don't forget your identities.
because they'll come in handy in the future.